Hi, so this is a video to walk you through some examples of paired t-tests, independent samples t-test, and ANOVAs in SPSS, very similar to the ones that you'll be doing for your fourth SPSS assignment. I want to reiterate that these are not the data sets you're going to be using for this. You're going to be using the healthcare or health data set posted in my courses for your actual assignment. But I am posting these data sets so you can follow along. You can also follow along with what we're doing here using the notes for comparing means using SPSS data set. Okay, so we're going to start with a paired samples example. I've got this data set where we've got students who took a placement test before they took a remedial math course and then after they took the remedial math course. This is a real data set that I collected from a course I taught a while back. Okay, so to get to the paired comparison, we're going to analyze, compare means, and then paired samples t-test. So that's analyze, compare means, paired samples t-test. And then we're going to take our placement test score after Math 99 and then subtract from it the placement test score before the course. Okay, and notice if you highlight or if you kind of hover over the variable name, you can see the whole thing. So this is after minus before. So we click OK, and you see the output. We really don't need the paired sample statistics or the paired samples correlations. What we do need is the paired samples test right here. This mean here gives us x bar d, so this gives us the mean of the differences, so that's x bar d. The standard deviation is SD, and then this is our test statistic, negative 4.469, so that's pretty extreme. And then our sig two-tailed is 0.003. That's the p-value if you're doing a two-tailed test. In this case, we didn't want to do a two-tailed test, so we're going to take that and divide it by 2. So here's that again. That's your x bar d, your SD, your test statistic, and then your p-value if you're doing a two-tailed test. So we did post minus pre, so your hypotheses are that the differences are greater than 0, and your p-value is 0.0015. And so remember, you're going to set up your hypotheses, state your test statistic and p-value, state the rejection rule, and then state both parts of the conclusion. To find the effect size, we've got x bar d divided by SD, and don't forget to take the absolute value, and so we get 1.5812 in this example. Okay, so that's that example. So that's for paired. Now if we move to independent samples t-test, if we want to test whether females have a longer attention span than males, then we're going to the attention span data set, and we've got gender here and attention span here. So to do the independent samples t-test, we're going to analyze, compare means, independent samples t-test. Our grouping variable is gender. And for gender, notice it says that you need to define groups. Let's go back and look at our variable view and see what those groups were. So for gender, if we look under values, it says 1 is male and 2 is female. So for defined groups, we're going to do group 1 is 1 and group 2 is 2. So we just had to check to see that the values were 1 and 2. So if we click continue, The attention span, this is our quantitative variable, goes to the test variable box, and then we click OK. And when we do that, we get a bunch of output. It's nice to have the group statistics here, so it tells us our mean standard deviation for the males and females. Here we're going to ignore the Levene's test for equality of variances. We're not doing anything with that ever. And remember, all the ones we've been doing in class, we've been not assuming that the variances were equal. Okay, so we're using this row, and for this one, our test statistic is negative 2.429. Our two-tailed p-value is 0.020. And so if we want a one-tailed p-value, which we said we do, in this case, we want to divide that by 2, so we'd get 0.010. So that's our test statistic and p-value. And this is the mean difference. All right, so if we look back at this again, so we've got this is our output. We're completely ignoring Levene's test for equality of variances. So you're going to set up your hypotheses, mu1 equals mu2 versus mu1 less than mu2 or greater than or not equal to, depending on what you're doing in the particular problem. You're going to state your test statistic, your p-value, and then you're going to state your rejection rule and both parts of your conclusion. And then when it comes time to do effect size, remember, is the mean difference, which is this value. You could get the same thing by doing the differences up here between the means, divided by the larger of the two standard deviations. So 3.68041 is the larger standard deviation. So that's how you're going to get the effect size. Okay? All right. Third example, the ANOVA. We want to test whether the mean happiness score differs based on marital status. So this is the happiness data set. Marital status, happiness, and I realize this variable eat friend sounds like cannibalism, but it's actually how many times in an average month would you say you eat a meal with a friend. So that's unfortunate naming. To do the ANOVA, we're again going to analyze, compare means, and this time we're going to one-way ANOVA. We're going to take our categorical variable, in this case marital status, move it over to factor. Our dependent variable is the happiness rating. So happiness rating, move that to the dependent list. Here there's one thing I want you to do under options. If you go to options and click descriptive, that's going to give us the mean and standard deviation for each of the groups. So click continue and then click OK. And then if we look at the output, we should see this is the descriptive statistics. So we get the sample size, the mean, the standard deviation for each of the groups. And then here's our ANOVA table. So for the ANOVA table, there's your F statistic, and there's your p-value. Here you're never going to divide that p-value by 2. It's just 0.542. That is what it is. Okay, and so now if we flip over here, you're going to set up your hypotheses. You're going to state this p-value and this f statistic, and then you're going to state your conclusion, whether you reject H0 or not, and then to do your effect size, you're going to the sum of squares between groups divided by the total sum of squares. And then that'll give you your effect size, and you can interpret that. Alright, so that's all there is. So if you have any questions, don't hesitate to shoot me an email. Alright.